Hello, I'm Nancy Strickland, and in this video I'll address some of the concerns that decision makers often have about the speed with which applications or services run in the cloud. Running applications or storing data in the cloud using Windows Azure or SQL Azure has many advantages, but because cloud resources are by definition located across a network, the performance of cloud-based applications will often show more latency, responses take longer to arrive, than with applications hosted on an on-premises server. First of all, I want to suggest that you can't make a blanket assumption that any cloud app will always run significantly more slowly than an app hosted on-premises. Network latency is unavoidable, but it's not the only component of overall application performance. Hardware and architecture also contribute. Windows Azure has several built-in features that help ensure that your cloud code runs as fast as possible in its cloud environment. The automatic load balancing feature of the Azure platform will make sure that incoming requests are assigned to the server with the greatest capacity at that moment, so you're less likely to experience avoidable slowdowns because of server overload. If your traffic should grow, whether in a short-term spike or over time, then you can easily add more capacity to handle the load and pay only for that added amount. This can keep your site from slowing down with the minimal effort and expense on your part compared to having to purchase and deploy new servers yourself. You can depend on it that Microsoft will always be deploying the top-of-the-line hardware and software for its Cloud Center servers. Since that's their business, they're going to upgrade to the newest and fastest technologies immediately, something that most enterprises aren't in a position to do. What I'm suggesting is that some of the reduced performance caused by transmission across a network may be made up for by top-speed hardware and an architecture that can eliminate bottlenecking. If the cloud makes sense for your app for other reasons, but you have questions about responsiveness, then it's probably worth spending a little time up front to investigate performance. You may find that a cloud app runs acceptably fast. To help you do that upfront investigation, Microsoft provides benchmarking of Windows Azure in different situations. The Microsoft Extreme Computing Group has a website. This is the link here, azurescope.cloudapp.net, and it provides benchmarking and guidance for Windows Azure. There are also a number of programming techniques that you can apply to your code running on the Azure platform to help performance, and there are built-in diagnostics and monitors and performance counters that can be added to your code to provide metrics to help you identify and solve performance issues if they come up. I'm not going to cover the specifics of programming techniques or how to add and use performance counters because those are technical topics and this is an overview for decision makers. But the same site I mentioned on the last slide, the Azure Scope site, also has code samples that illustrate performance for some common end-to-end application patterns, and it provides the source code so you can use it in your own development work. You can also search MSDN, the Microsoft Developer Network, and the Windows Azure site for other sources of help. Finally, I want to point out what's obvious, that any choices you make about computing platforms involve trade-offs. In cloud computing, you get scaling, reliability, high availability, and lower cost, and one of the trade-offs that you may have to make is performance. If optimal performance is your only concern, or if it outweighs these other advantages, then you may not be able to use a cloud platform. But if you need to balance several considerations, then you may choose to move to the cloud and find that you can get all the performance you need and the other advantages of the cloud as well. You can keep up with what's new on MSDev on these social networking sites. Below the Twitter logo is my personal Twitter ID. I use it to announce new videos as they're posted, so you can follow me if you want to find out about that. Thanks for watching. Bye-bye.